What's up, young squids? Mr. Solodker here with another mind-numbing video about chemistry. Two things I want to say. First, that noise you may hear in the background is my air conditioning. Please don't complain about it. Second, there are only 2 instead of 4 problems on part 2 of the test. For that, you can thank me by solving the 2 problems correctly and not acting like a squid in class. So let's get the fun started. Alright, so in this problem, it says that how many grams of lead 2 nitrate are needed to react completely with a 50 milliliter 0.75 molar potassium chloride solution. So you're going to have to do a lot of things in this problem, and so to somewhat simplify those things, I have tried my best to help you organize this information. So we will start off with the very first thing you need to do, which is you need to predict the products formed. So this is your reactant number 1. This is your reactant number 2. Notice that I'm not asking you to find their formulas first. I'm asking you to predict the products formed. There's a very simple way to do that. All you need to do is use a different color. See this lead? This is a positive ion. And you see chloride. This is a negative ion. Similarly, you've got potassium, which is positive, and nitrate, which is negative. And so all you need to do is combine them as indicated by the 2 colors. So we'll write down what the products are. There we go. So those are my 2 products, lead 2 chloride and potassium nitrate. Your next step in this problem is going to be figuring out the formulas of all 4 chemicals. What are those 4 chemicals? Lead nitrate, potassium chloride, lead chloride, and potassium nitrate. So take a minute and figure those formulas out. Now what I'm going to do is I'm going to quickly go over how to write formulas. This is something that I feel I shouldn't have to, but I think I have to. So let's see. Lead 2 nitrate. We know lead is Pb, and then you see here's a Roman numeral 2. This Roman numeral 2 means that you have 2 positives, and nitrate is NO3, which from the list of your polyatomic ions you should know is 1 negative. And so in order to balance these charges out, you will need 1 more negative, which should give you the formula of Pb parentheses NO3 2. I had to put parentheses around my nitrates because it is a polyatomic ion and I have multiple of those. See, I have 1 and I have 2. I had 2 ions, so there you go. I've gone over this, so hopefully you should be able to figure out the formula of potassium chloride, lead chloride, and potassium nitrate. Moving forward, what I have done is I have taken the reactants and the products and I have set up my balanced equation. Now I don't think I have balanced this equation, so I do need to put a 2 over here and likewise a 2 over here, and that should be it. Yes, it is. So your coefficients are 1, 2, 1, and 2. So let's move on to the calculations part. So how do we do these calculations? You have to start off with what's needed from me. Okay, that is the number 1 question you need to ask yourself. What do I need to find? and this part of the statement tells you what you need to find. It says how many grams of lead to nitrate. So what you're trying to find is grams of a chemical. So take your minds back to that chart we made over stoichiometry. I think we titled it a mole chart or something like that. Okay, and so what you're really trying to find is moles of B. Let me correct that. What you're really trying to find is grams of B. So let's see how we are going to set up the problem first, and then we'll worry about the numbers. In this question, lead nitrate, which is this chemical right here, is your B chemical, and potassium chloride, which is this chemical right here, is going to be your chemical A. Now, what do we know about chemical A? We know that there's 50 mils of it, and it has a concentration of 0.75 molar. Using these two pieces of information, and by using this formula, you can easily find out how many moles you have. All you need to do is put the numbers in and multiply these two, and you should have your answer. So now that I know that I need to figure out grams of B, you need to take your focus over to the A side of the chart, where you have your grams of A, liters of A. But what you really want to find is moles of A. Once you know moles of A, you can then figure out your grams of B. So what is B and what is A? Remember, B is the name of the chemical you're looking for, and A is the name of the chemical that is given in the question. So let's go back to the question. After multiplying, the answer I got was 0.0375. moles. Okay, now you will need to set up a stoichiometry chart and figure out how many grams of B does that give you. I'm going to start my chart with the given, which I just found by multiplying the molarity in the milliliters, right? So I mean the liters. And so the answer I got was 0.0375 moles. I am going to copy that down on the bottom as is, and then convert it to moles of my needed, which is lead nitrate. Copy that down on the bottom as is. So moles of PbNO3, and then turn it into grams. So at this point, I've set up my chart. For a mole to mole conversion, which is this right here, this is a mole to mole conversion, you are going to have to refer to the balanced equation and get the coefficient for both of these chemicals. So if you go back to your balanced equation, then KCl was 2 and PbNO3, okay? Then you put 1 mole and you find the molar mass of PbNO3, which is 331.2. So all I got to do now is multiply my moles by the molar mass and divide by 2 and calculate the answer, which gives me an answer of 6.21 grams of PbNO3. And that, my squids, is the answer to this problem. It means that if you have these many grams of this chemical, then it will react completely with all of this. Alright, so that is the first type of problem that you will have on your test. Now let's get on to the second one. Alright, moving on to the second problem. Now this problem might look a little convoluted. It is certainly a little different than what we have done in class so far, but I just want you to stay with me and stay focused, and we will get through this one. Now let's see what we have. We have two chemicals here. Your chemical number one, which I'm marking in red, is hydrochloric acid. Chemical number two is sodium hydroxide. They react together and make something. We'll need to figure out what that something is. Let's see what information do we know about sodium hydroxide. We know we have 50 milliliters of it, and we have 0.05 molars. We also know that we have 50 milliliters of hydrochloric acid, but we have 0.5 molar hydrochloric acid. So clearly you can see that the concentration of hydrochloric acid is much higher compared to the concentration of sodium hydroxide. So I predicted the products using the exact same technique I talked about in the first problem, so please refer to that if you need help. And then I set up a balanced equation since you already knew all the formulas. Sodium chloride is NaCl, H2O is water. So this happens to be a case where the equation is already balanced. On your test, you might encounter an equation that is not balanced. Please don't come at me saying that this problem is nothing like the one you did in your video. Okay? Just balance the dang equation. I'm just kidding, guys. You know I love you. Set up a balanced equation. So this equation is already balanced. Your coefficients are all ones. So let's move on to the next part. For that, we're gonna need to go back to our balanced equation, and your balanced equation tells you that your mole ratio for hydrochloric acid and sodium hydroxide is 1:1, which means that for every mole of hydrochloric acid you need 1 mole of sodium hydroxide. Alright, so on the screen you will notice that I have made two little columns, hydrochloric acid and sodium hydroxide. I wrote down what I have, what was given to me in the problem, which was 50 mils of each chemical and their respective concentrations. And so what I did was I multiplied the volume and the molarity for both chemicals, and I came out with moles of hydrochloric acid and moles of sodium hydroxide. Please remember that you cannot multiply molarity by milliliters, you have to multiply molarity by liters. I skipped that step because I'm sure you guys know how to do it correctly. Now, what do we do with this information? You will notice that compared to sodium hydroxide, I have a lot more hydrochloric acid. Okay? What does that mean? It means that when these two chemicals are mixed together, your sodium hydroxide is going to get used up pretty quickly. Okay? So this is my limiting reagent. Remember that term? Boy, that was fun, wasn't it? And this is my excess. Okay, I call it excess because I have more of it. Now, how much more hydrochloric acid do I have compared to sodium hydroxide? In which case, if you have 0.0025 moles of sodium hydroxide, then obviously you're going to get the same amount for hydrochloric acid, and so all you need to do is subtract. So 0.025 minus 0.0025. Okay, it is very important that you understand what these two numbers represent. This first number is the beginning. Okay, so this is how much hydrochloric acid I had. in the very beginning of the problem. The second number is how much I used, okay? And so the answer is going to be your balance. How many moles of hydrochloric acid were left unreacted? 0.0225 moles of hydrochloric acid were left unreacted after the reaction was completed. And this is a very important number because now you are going to use this number and figure out the last part of your problem, which is asking you to find the molarity of the resulting solution. And so if it's asking you to find molarity, you have only one option, which is to use this formula: molarity equals moles over liters. Now, here's the thing. We already found this. What about my liters? Well, if you go back to the beginning of the problem, you will remember that you had 50 milliliters of each solution, right? Now, what is a solution? It's just some solute mixed with water, right? Now, one of the two solutes, sodium hydroxide, was completely used up. You don't have any more sodium hydroxide left, but you still have the 50 mils of water that you had dissolved it in, right? What does that mean? It means that now the total volume that you have in your flask or your beaker is 100 milliliter. 50 milliliters from the hydrochloric acid, 50 milliliters from the sodium hydroxide. But because we cannot use milliliters, we divide it by 1,000 and we get 0.1 liters. Now that you have 0.1 liters and you know how many moles you had, all you gotta do is plug in the numbers and get your answer, which is 0.225 molar. Alright, so this was a long one, but let's see if our answer makes sense. Look at the number we got. We got 0.225 molar. Compare that number to the molarity of your hydrochloric acid, which was 0.5 molar. Now, if you were to do some quick math, you will notice that the answer we got is a lot less compared to the original molarity. Does that make sense? Well, yes, it does, because two things happen. First of all, you used up some of your hydrochloric acid to react with sodium hydroxide. Second of all, your volume went up, right? If you look at the equation for molarity, the volume is on the denominator side. If the value of this denominator goes up, then the value of molarity goes down, which further contributed in your final resulting molarity being a lot less compared to your original molarity. Alright, so these are the two problems. I think I have sufficiently confused you, but I'm also going to tell you that you are not going to do well on this test if all you do is watch this video once, copy down everything I have on the screen, and show up to the test. Okay, you really do need to understand how I did this problem. If you have any questions about this, please ask me on Tuesday before you take this test on Wednesday, because if you don't ask questions, then I have no choice but to simply assume that you understood the material. Okay, so please participate, please ask questions. Have a fantastic weekend. Happy Easter. Please don't eat too many candies. Please brush your teeth. And I will see you on Tuesday.